Question is given, draw the circuit diagram of obtaining VI characteristics of PN junction diode and explain briefly the salient features of the VI characteristics in forward and reverse biasing. So VI characteristics of the PN diode. So draw the VI characteristics. So this is the VI characteristics. So this is the VI characteristics. So VB is the barrier voltage, VBD is the breakdown voltage. Barrier voltage, that is in forward biasing. Barrier voltage in forward biasing. So breakdown voltage in reverse biasing. Barrier voltage in forward biasing, breakdown voltage in reverse biasing. And explain the features of VI characteristics for forward and reverse biasing. In case of forward biasing, this after breakdown voltage current conduction increases, and in case of reverse biasing, after breakdown voltage current conduction increases. After barrier voltage current conduction increases, after breakdown voltage current conduction increases. Forward biasing, reverse biasing. In case of forward biasing, current conduction increases. In case of reverse biasing, current conduction decreases. Junction resistance decreases. Current conduction increases. Junction resistance decreases. Here junction resistance increases in case of forward and reverse biasing. Then next is key on the basis of energy band diagram, establish distinguish between insulator, semiconductor and conductor. On the basis of energy band diagram, establish the distinguish between insulator, semiconductor, conductor. In case of insulator, no current conduction takes place. No current conduction. In case of insulator, no current conduction. No current conduction takes place. So what is the energy band diagram? Draw the energy band diagram for insulator. Draw the energy band diagram for insulator. For insulator, the energy band gap. For insulator, the energy band gap is how much? For insulator, the energy band gap is greater than 3 electron volt. For insulator, the energy band gap is, for insulator, no current conduction takes place, and energy band gap is how much? Energy band gap is greater than 3 electron volt. For semiconductor, partial current conduction takes place. For semiconductor, partial current conduction takes place. For semiconductor, partial current conduction takes place for semiconductor. So what is the energy band diagram? Easy, energy band gap is less than 3 electron volt. In case of insulator, energy band gap is greater than 3 electron volt. In case of semiconductor, energy band gap is less than 3 electron volt. And in case of conductor, valency band, conduction band overlap on each other. In case of conductor, valency band, conduction band overlap on each other. And here current conduction takes place. And here current conduction takes place. And here current conduction takes place. So this is in case of conductor, in case of semiconductor, in case of insulator. So that is the energy band diagram explanation. In case of insulator, energy band gap is greater than 3 electron volt. In case of semiconductor, energy band gap is less than 3 electron volt. In case of conductor, the band gap, the valency band, conduction band overlap on each other. So that is energy band diagram for conductor, semiconductor